For a while, we have not done a Unity tutorial for a while. So I'm going to show you today how to create a path, like a spline curve in 3D in Unity. So this is my program that this has been eating up all my free time. When I'm not playing Diablo 3, I'm working on this app exclusively. So this is my app, Touch Animator, which is, I'm controlling this right now from the iPad. So this is, my hope to build a fully functional 3D animation program for touch devices like iPads and tablets, possibly Android tablets in the future if they take off. So as you can see here, I can just easily, of course, like I said, I'm controlling this from the iPad right now. I can easily go ahead and set the, it's the combination of the Unity remote and the screen capture software is making things a bit slow, but trust me, it works really fast on the iPad by itself. So I have the ability here to edit the path that I just created. Alright, so here is the path, and if I go into my scene and just spin this around, you can see that this path is actually completely three-dimensional. Alright, so what I can do is I can grab any of these little balls here and I can edit the path just dynamically by dragging it with my finger. Alright, so you can see that this path object is completely animatable itself. There we go. You can move these around. I have to turn the sensitivity of this path editing down, but that's, it's still a work in progress. And it works. You can see once I deselect the path, if I go ahead and scrub through the frames, you can see that it in fact is following the new path. So what I'm going to show you now is basically how I created that path in 3 dimensions in Unity. Alright. So what I did was I created a empty game object. I went to game object create empty. In this case I called it path drawer. And then with that object selected, I went to component effects and added the line renderer component. So we can take a quick look at the line renderer component over here. Basically, I turned off, in this case, cast and receive shadows. I don't really want it to cast and receive shadows, not part of the scene per se. And I gave it a new material. I think by default it's the awful pink material or whatever. I just clicked on the little select material button there and just gave it this kind of bright blue material. The rest of it I pretty much left to itself. I kept the start width and end width to be the same. You can vary the start width and end width to give different effects like laser beams or blasts coming out or something like that. Alright, then finally I went ahead and I attached create a script and attached it to this object. I'm calling it path drawer script. So let's take a quick look at that script. Now a lot of this is going to be referencing other components in the scene, of course, but in code works. So the first thing I did was I created a variable to reference the line renderer component, calling it LR. Alright? Then I went in my start function, I said the line renderer equals this, meaning this game object, dot get component line renderer. So now I have kind of access to this component. I can manipulate it in script. Okay, so the next thing I did was I set the number of vertices. Alright, so the line renderer is going to create like a three-dimensional shape that goes through 3D vertices in your scene. So I set the number of vertices equal to the number of animation frames we have. So if you remember here, alright, get this to run. So down here you can see I have, in this case, 90 frames, and this little timeline down here shows you the number of frames that we have. So it's going to loop through 90 times in this case. If it was 30 frames, it would loop through it 30 times. Alright, and then what I did was I need to get the data to create the actual points in 3D space. So in this case, every part of the object of this little animation character here is referenced by a tag called joint. So his hand, his elbow, his head, his torso, his knees, his feet, everything is called a joint. And I have animation curves that's driving the animation of these joints. I create the animation curves interactively, as I showed you before, by dragging in the window. Alright, so what I'm going to read, only the position data from the animation curves are driving the object, because obviously rotation data is not going to give you any kind of points in 3D space. So I'm reading the actual path that this object has taken, I'm going to put that that data into the line renderer as these position objects that it goes through. So you see here by default, I think it has 2 positions by default. You could add these in here just by clicking in the size variable and adding so you can manually type in the paths to this thing, but we're going to do it in code here. So in order to go through my list of objects, I created an empty game array, okay, an array of game objects rather, and then I populated that with all the objects that have the tag joint. The next thing I did was loop through that array of game objects, all right? And each time we loop through, we check out one of them called mob check, all right? Then I'm going to get the script attached to that game object. Because I only want to show the data of the selected joint, I go ahead and do this little check to see if the name of the current joint that we're looping through is the same as the selected joint name, all right? Okay, so the next, once we've got the the selected joint, then we're going to loop through its animation data. Okay, I created a variable here called keytime, and this is I'm going to use this to step through the animation curve data. I'm going to keep incrementing this keytime variable, and I'm going to use that to get the value from the animation curve. And the way you get a value from an animation curve is, so here's the joint scripts. I have 3 curves here to manipulate the X, Y, and Z translation. I'm calling them X trans curve, Y trans, Z trans. The way you get the animation data at a certain time is with this keyword called evaluate. So I'm evaluating the curve at that time, and then I'll just simply keep incrementing this keytime to go through all the animation frames. So I get the X, Y, and Z values of those curves, and then I put those into a new vector 3, which is what the line renderer is going to expect. Vector 3, of course, is 3 positions in space, and so then I finally set I set a position for the line renderer, and I'm just looping through. I give this variable called I to loop through the number of. You can see here as we're looping through this with the 4 value. I just said, okay, position number. So that's here. Position number I is going to get this new position. All right, and then I go ahead and I just increment my key time. All right. Okay, and the final thing I did was I'm showing and hiding this path with this little bit of code. All right. So what I did was I have this variable called show edit tangents, which is what I'm using when the user. Come on, it takes a little while to run it when it first starts. When the user taps on this edit path button, you won't see anything now because there's no animation data, but when the user taps on this edit path button, that variable gets set. And what I'm doing is, I'm doing a little trick here. I'm just setting the width of the line renderer to this certain amount, like in this case 0.1, 0.1. And when that variable is not set, I just set the line renderer's width to 0, 0. And that way you're kind of showing and hiding without having to keep deleting and re-adding game objects. I just show and hide it. So that's basically how to create a 3-dimensional path in Unity. I also taught you, kind of by the way, how to loop through a list of game objects, and how to evaluate an animation curve. So I hope that those tips will help you out.